Hello guys, today I'm going to make a tutorial about PBR or physical based rendering because I've been touching this subject a bit on the Artist Guild and people find it interesting and really helpful, and I thought I might show some more stuff. I made this video for more to 2D artists, not really for 3D artists, but this is to understand like materials, so I hope you enjoy. Hello guys, today I'm going to show you physically based rendering. And we're going to talk about everything on this screen. So we're going to talk about diffuse, gloss, SSS or subsurface scattering, for now, refraction, highlights, and some other rendering incidents. So let's go talk about diffused. So, bugger. That's a problem. Let me just clean up my doohickey. Alright, so I'm trying to get the most realist state as possible. There we go. So we're going to talk about diffuse. Actually, let's go talk about what a light ray is. So a light ray it's a wave, and it could be in a wavelength from the visible spectrum, and that's what determines the color we see. And depending how large that wavelength, different colors. So we can see colors from 400 nanometers to 700, and that's the visible spectrum for us. But we know in the light spectrum there's heaps, like really small, like a tiny bit. So here is, we see, we got like gammas here, we got radio waves down here, X-rays, ultraviolet, the whole spectrum. Oops. And light interact differently on different types of surfaces. And the first surface I like to talk about is a diffuse surface. So on a diffuse surface, it will have little imperfections, little crevices, little bumps. Let's go pick a pretty color. Let's go pick, so there'll be like little imperfections. And when light will interact it, pick red. Oh, I like to mention this is meant for like 2D artists. So when light will interact a diffuse surface, it might hit here and bounce that way. It might go this way. It's all very uniform. Alright, so this is what a diffuse surface would be, and this would be like really microscopic, like really tiny. But on the surface it might just look flat, and we're going to no, I don't want to see it right now. And we're going to see, oh dear, bang, and we're going to see a visual representation of this in Blender. So a diffuse surface in real life, it probably look like a plastic, but the one that's not very shiny. So I'm going to use this model here, Faithy. This is our model, Zona Render. It looks very cool. Really right to render out. Alright, so I'm going to delete its materials. Bye. And I'm going to add a material. We're going to delete the principal BSD, and we're going to add a diffuse shader, a BSDF. I'm going to plug it into the surface. And this is what diffuse will look like. So it's a very flat, it's very matte look. there's not a lot of real life examples of a perfectly diffuse because there's no such thing as a perfectly diffuse. We can change the roughness. The roughness means like how basically how bumpy that surface will be. I guess we can go into EV, which is a little bit faster. Yeah, literally nothing. So there's no like reflections, no highlights, no nothing. It's just a diffuse. Light is being hitting onto the surface and being scattered away, like diffuse. So this is what a diffuse surface would be like. Next up, let's go talk about a gloss surface, like a glossy surface. So a glossy surface, the atoms will be so on a glossy surface, the atoms will be a lot more uniform. All right. Oh, come on, there we go. So the atoms will be a lot more uniform. Oh my god. So the surface will be a lot more flatter. And the light ray, we all know this. So we got the normal here. Normal means the perpendicular surface. Maybe we should use a different color. Maybe blue. So we're gonna have a normal here. I won't go dive too much deep into the math. I just use its technical name and what I know. So here's a normal. A normal means a perpendicular surface. A normal. It's really imaginary. And light, and on a glossy surface, light will perfectly ricochet its angle. Its what's it? I forgot what's this called. Its incident ray. No, the angle of the. I forgot what's it called. Angle of depression. And this is the angle of incidence. Will be the same angle as it will enter. Here, I'm pretty sure. We don't know what this means. That's how light will bounce off a glossy material because all the atoms are uniform. And there won't be just one of this. This is only a long light ray, but there'll be multiple. So oh thank goodness. So Shift D, I can do this. So there'll be multiple of these instances will be happening. So light will be all perfectly bouncing. And something special will happen on the glossy material. So let me change this out. Shift A, and we're going to get a gloss shader. We're going to plug this in. We're going to start to get highlights, and we can change the roughness. It basically means how perfect that surface is. So we can see on a perfect, with zero roughness, light is perfectly bouncing from its environment. So we see everything. So it looks very metally. So we can see it's acting like a mirror. So we can imagine light rays are bouncing from here and into the camera, or into us, into our eyes. And same for refraction of this, but that never happens. So it'll be more like this. And if I add a light source, make sure, yep, point light, G shift Z. There we go. We have a light source happening. We can see the light bouncing the light ray into our eyes. And I'm going to try to turn up the power. Alright, there we go. But there is what's it? But there's actually but human skin is diffuse and also part glossy, but we need somehow what's it, mix both of these properties together. So I'm going to quickly add that. So I'm going to just quickly grab a diffuse shader and a gloss, no, and a mix shader. Where is it? Here it is. And we're going to plug this together. And we're going to try to get some realistic colors, huh? So diffuse will be like this. And we kind of got somewhere similar to skin. And we can see we've got our highlighter happening here, and our diffuser happening here. But so it's a mixture of what's it called? Of diffuse and glossiness. But this is not true for all situations, because we kind of get this like this diffuse and glossiness happening all around here. It's like perfectly uniform. We can have a factor here, like we can change how much. It's either 100% of glossiness or 100% of diffuse, but I can choose it in the middle. But let's go think of another scenario. We're gonna talk about Fresnel. Fresnel. Fresnel is pronounced as Fresnel is actually French. So we're gonna skip SSS, but we're gonna talk about Fresnel. Fresnel basically means a special at a certain angle, a surface might be more glossy than diffuse, so one another. And I can plug in a Fresnel shader, no, a Fresnel factor into here. And hang on, nothing much happened. Maybe I have to change the IRL. Usually. Let's switch these around. So basically what's happening, anything that's like near 90 degrees from our viewing angle. So let's go draw a quick diagram. And merge all these slides together. So a quick diagram we're going to draw here. So I'm going to draw a curved surface here. And let's go talk about Fresnel. So light, so here's we're going to have our emission source here. And we're going to have our camera here. Alright, this is our eye. Here's a little eyelashes. I could do better. So the light will be, bouncing around back to us, and it might be diffuse here. This one here might scatter off and might show a bit of its environment because the light be bouncing here too. And as we get further along this curve, light will start to will be more glossy because they right here they can't bounce back. Well, of course they can, but it'll be more of it will be bouncing away, and that's why this here, the surface here, become more glossy. A good example of this will happening if you grab a marble. I think everyone will have some marbles, and I hold a marble, but towards the edges it will start to be glossy or translucent depending on the surface. And I've set this up on Faith. So only on angles like here, like basically near 90 degrees from us, it starts to become glossy. right? So anything near 100 near 190 degrees for us, it becomes glossy. And IRR stands for what's it called? Incidence of refraction, something like that. And of course I can control this. Oh, maybe 0.5. No, that's basically become 9. And skin is actually a mixture between gloss and shady. Gloss and diffuse. There we go. I think that's a lot more realistic look. I think this would be better for metal. It's a really bad thing. So that's for now. For now, will happen to surface like water. Like a good example is when you're on a lake. If you look directly, like 180 degrees into the water, perpendicular to the surface, it becomes translucent. But if you look parallel to the surface, it becomes reflective, like the lake perfectly reflects its environment. Alright, let's go. So that's what for now is happening. And also, I'd like to talk about why highlights happen. So I'm going to draw a quick ball. So highlights will happen all the time to curve surface, and also texture got to do a bit of it. So I have a ball here. Oops, let's go pick a dark color because we're going to pick a diffuse color. I'm not going to talk about shadows because that's light path being blocked and other stuff. So protect alpha. I'm going to make it a lot darker here. So here's this cast shadow does amp. It's cast shadow. Here's its simulated what's it called? Ambient occlusion shadows. And of course, here's the highlight. Alright, so what is happening here is exactly, again, we have a curved surface. Oh, I think curved surface here. Well, I'm going to pick it's the base color. Make it brighter. We have a curved surface. Let's, for all sake, let's just think of this material, just glossiness. We won't think about diffuse. Just you can think of diffuse, but it's basically really minute. It might be bouncing some light that way, all over the places. And we're gonna have our camera. Here's my lazy camera, and here's going to be a light source. So the highlight will happen here. But everywhere around this will be light be showing because light will be like bouncing this way and some that way. But where the highlight is happening, it's the exact perfect angle where the light is bouncing into the camera from the emission source. So here's a camera. This is the blended camera setup. I don't know if you can tell, alright? And everything else is like being scattered away. A good example of this is when you ever there's times when you play with a mirror and you just hold it. It's not, and you try to shine the reflection into someone's eye, yeah? You need to find the perfect angle where it will bounce the light into someone's eye. Since it's a curved surface, it's trying all the angles at the same time. So eventually down this curve, you'll find the perfect angle that will bounce a light path from the emission source into the camera, and that's why a highlight will happen. Because I don't like how 2D artists have been learning how highlights happen. Highlights happen because of they think of it like it's like the mountain peak. Well, it's the perfect angle or the perfect surface where light bounces into the camera or into the viewing source from the emission source. Alright, so that's all pretty cool. So that's some incident rays. So let's go talk about subsurface scattering. And subsurface scattering is super important because it's the last part of what's it? Of human skin. So subsurface scattering, it's have a thickness. It will need a thickness. It's not like a and basically what will happen, the light ray will come in and will penetrate, and then it will hit all the little objects in here, and you know, it'll be just a mess. You know, it'll bounce around a few bit of times and might exit in a complete different direction. You know, there might be like a little blood molecule, more blood molecules. They're basically it'll be hitting all these little things, all these imperfections, and of course there might be some coming directly out to you. But just imagine there's like hundreds of this. So let's go see a visual representation. I guess we could do both. The gloss. I think you understand. I want to show you the highlight because I guess you know this is where the light's sort of perfectly bouncing to us. But let's go talk about subsurface scattering. Alright. I'm going to do a little bit of node magic. Eevee does not render out glossiness and subsurface scattering well. It crashes on my computer. So I'm going to quickly build a little node setup. We're going to get what is it? Shader, subsurface scattering. Shift A. We're going to get a mix shader, and we're going to just plug in this magic. Very cool. I'm going to get in a texture map, image shader. So basically it's just telling this part's red, this part's will happen more. Where is it? Image. Texture, image texture. I'm going to plug this both in here. Now it's black because there's no information coming in. And I need to find it. Here we go. Alright, that's really disturbing. Alright, so what's happening here? Some part is being diffused, and some part where it's really red is being refracted. I think it will happen a lot better into cycles. So I'm going to get the cycles render engine on. And I'm going to turn up the strength to like a ridiculous number, like 1000. I just want to. Now we need to wait for this to render. Here we go. We see the light bound. It's slightly transparent, but we can see the light entering into her nose and exiting out in a red color. So that's what's it? Subsurface scattering is. You can see it happening to her chin. So the light is entering into her nose. It's being scattered around and then exiting out in a different direction, giving this glow. So that's what subsurface scattering is. It's very important why you need to add the redness into your characters, otherwise your characters will look a bit dead in the end. So that's some subsurface scattering. That's what else we have to talk about. For now, refraction. Oh, I seem to lost my canvas. Oh dear. Alright, refraction. So refraction is basically like glass, I guess. It's kind of similar to subsurface scattering, but it's kind of like the glossy version of subsurface scattering. Like if I had to say subsurface scattering, got to be the diffuse version, but let's not figure that because they're all different. So refraction will be similar to like glass. Basically, the light ray will come in. Ooh, that's not what I want. So the light ray will come in and bend a different direction and then exit out. So you can see that's like this visible curve. So it's why like when you look at a cup of water, the image behind of it's like the environment behind it will be warped because this is what's happening. The light's being bent and warped inside the glass and inside the glass of the water. So that's what refraction is, and we can see a visual representation of this. Yeah, we can see the translucentness into her nose. Oh, I really don't want to move that, I'll just have to re-render. Oh well. So we can really see the translucence in the nose. And it makes it look alive. I guess fruit does this, everything do this. Everything has subscattering to some degree. It's really minute. You might notice it. Wood even have it. But it only happens at certain conditions. Alright. So let's get a glass shader. Glass, gloss, all thing, they're all the same. So right now it's refracting the light. Oh, we've got some Fresnel business happening. Like some part is less than the other. Maybe I just go straight to a R refraction BSD. Yeah, see, it's bending the light. It's bending and twisting the environment behind it. Maybe I can turn up the roughness. Oh, the roughness making like it's scattering inside too. It could be like subsurf. The IR, this is like from the. Let's go set that to 0.9. And we get less of this black. Alright, cool. So I guess that's what refract is. So now I have a glass girl. One more thing I'd like to talk about is emission. So emission will basically be expect the light is coming out like this the object of the material is giving off light, like lights, suns, stuff like that. And I guess this I guess we need to mix a diffuse, because if you look into like one of those light bulbs, it's actually like a mixture of like glass and diffuse. So we can't really see anything happening. Alright, there we go. I guess we won't need this. We can turn up the strength. I'm gonna make this like a black, a different color. The emission color could be something fun. Alright, really needs environment, black, G. And we should start to see the light. Maybe it's like the environment light may change. Alright, there we go. I made the environment pink. It basically there's the information or data has been lost. But we can start to see the emission light, and then by default all materials are diffused, like to some degree, and light's being bounced off into back to us. and that's what emission is. So I hope that gives you some basic ideas about what physical based rendering is, some basic lighting scenarios. We got refraction. I need to go turn this off. Refraction, highlights, why highlights happen. For now, that's a pretty important concept. I basically just mumble my way. I apologize. Yeah, okay. I'm going to end the video here because I don't know what else to talk about.